Hi everyone. Today I'm going to talk about sine and cosine graphs and what they actually look like. Now, for the purpose of this lesson today, I'm only talking about sine and cosine graphs that are of the general form given here, where y equals a sine nx. So, a couple of things about this. First off, the a in this case represents the amplitude of the function, okay, that is how far it deviates either side of the x-axis. The n represents, well, a dilation factor from the y-axis, but it affects the period of the function. You can see I've just written down here for these two functions, the period, or the time that it takes for the function to start repeating itself, is p equals 2 pi over n. So we have that very clear link right from the word go. Now, these are the two shapes of the graphs, so you can see that they are very similar. The sine curve starts at the origin, increases and then decreases, passing through 0, pi and 2 pi. The cosine function starts up at positive 1, decreases until it reaches minimum at pi, and then increases again to a maximum at 2 pi. So it passes through pi on 2 and 3 pi on 2. Now, we will get into the tan function a little bit later, so let's not worry about that. But what I will say is that given that I was able to sketch these graphs as accurately as I have using a computer, you should be able to do it even more accurately in your workbooks. Oh, that wasn't what I wanted. Alright, there we go. So, we have just a couple of questions here. The first one is to state the amplitude and period of these functions and then sketch the graphs of them. So we can see in the first one y equals 2 sine 3x. The amplitude is going to be given by this 2 here, and the period we will calculate using this 3 here. So just on the side I'll write a equals 2. That means it's going to deviate 2 units either side of the x-axis. The other one is the period calculation, so p equals 2 pi over n. In this case, n is 3, so p equals 2 pi over 3. So that means that it takes this graph 2 pi over 3 units for it to start repeating itself. Now, we are just sketching one full cycle of this. I know that the sine graph starts at the origin. So it has this point here, and then it's going to finish at 2 pi on 3, so I'll mark that over here. So it's also passing through there. It's going to pass through exactly halfway between those as well, so halfway between 0 and 2 pi over 3 is just pi over 3. And then I'm pretty right to sketch this. I know that the maximum will occur halfway between here and here, which would actually make it pi over 6. So that will be an important point as well. And if that's 2 pi over 6, then this here is 3 pi over 6, which is the same as pi on 2. So from there, I know that it's going to reach a maximum up here, and it's going to reach a minimum down here. And so I can then sketch the curve, making sure that it passes through all relevant points, like so. And I should also point out this is going up to 2 and down to negative 2. So the other example here, the equation was 1/3 cos pi x on 2. Looks a little bit more complicated. So again, in this case, the amplitude is the number out the front, which is just 1/3. We still calculate the period with 2 pi on n, but this time n is actually pi on 2, because that's what the x is being multiplied by. So we have 2 pi over pi on 2. The pi's will cancel each other out, and that should leave you with, well, it's just 4, isn't it? Okay, so it has a period of 4. That means that it is going to have an important point at 2. It's going to finish at 4. It had an amplitude of 1/3, so it's going up to 1/3 and down to negative 1.